Yes. So is it on? Yeah? Okay. So I'm gonna talking about WebSockets. I'm on Twitter and on GitHub and on Facebook if you want to learn more about WebSockets and all the stuff that I'm building every day. I got my own consultancy company where I basically consult people about real-time applications, about the bugs they find, and just trying to help them get along. I'm also I'm lead software engineer at Nojitsu. We host Node.js applications, but we also host private NPM. So if you're still deploying to production using Git, don't do it. Just get a private repository. It makes everything much better. So yeah, I'm going to start off with talking about the good parts about WebSockets. And the good parts is there are already a lot of browsers, basically all of them, that are supporting the latest draft of WebSockets, the latest RFC of WebSockets. We still have like IE 10 being the latest version for IE to support WebSockets. So if you're still supporting all the browsers, WebSockets might not be the good technology for you to use to build a real-time application. There are already older drafts in all these browsers, so if you want to support more WebSocket drafts on your server, you will have a much more wider browser support. So you can start off with Chrome 4, Firefox 4, Opera 11, but Opera 11 that is behind the configuration flag. So users must be able to enable that themselves or it will just not work. But still, IE 10. Also, it's bidirectional, so it only uses one connection to send the data and to receive the data from your server. It makes it really lightweight for your web server because it doesn't need to use a lot of HTTP connections just in order to stream all the data back and forth. And of course, it supports binary data. And that's it. That's all the good parts about WebSockets. So we're going to move on to the part that basically nobody told you. And this comes all from experience from building a huge WebSocket auction site. And we had the fortune of having customers that dialed us, calling us, hey, we can't bid on auctions, nothing is working. And some of them helped us step through a lot of these processes and bugs and figure out what was actually broken, and most of the time it was just WebSockets. One of these causes was if you're using a Mac, and in your network settings you have this auto proxy discovery turned on, it will actually just fully crash your browser when you instantiate a new WebSocket. You can try to wrap it in a try-catch statement, but it doesn't help. It just fully crashes, and there's nothing you can do about it. This is all in older versions of Safari. But still, if you want to support all the Safaris, like Safari 4 or 5, this is not something you can go around. You have to use really horrible user agent sniffing in order to get around this. So in these slides, I assume you all speak jQuery fluently. So this just does detection to see if it's Safari and not Chrome, and just gets the right WebKit version, and just don't decide to use WebSockets because it will crash and there's nothing you can do about it. There's also a really nice bug on iOS. It's that when you're writing to a WebSocket that's been closed, it just fully crashes. And you know that there might be a ready state on the WebSocket instance, but if you check this ready state, it still says it's open. So you can still write to it according to the WebSocket instance. But this is definitely not the case because it just causes a full browser crash on your phone. The only way around this is to add a really small set timeout when you start writing it, but be sure that you're only doing this for mobile and basically only doing it for iOS. Because when you're building real-time applications, you don't want to introduce these kinds of latencies because it's around 10 to 50 milliseconds for each message you want to send. And that just adds up. It's not something you want to do if you don't have to do it. There's a really nice bug in all the Firefox browsers. When you press the escape key, it closes the WebSocket connection. This makes sense when you're still loading the page, because that's most of the time your intention, just to close all resources and just go to a different page. But when your page is already fully loaded, it's not something you expect. You will most certainly bump into this when you're building a game and you allow users to pause the game, because the first instinct is press escape just to pause the game, and before you know it, your whole connection and your game is dead. Same thing with model dialogues that pop up. Users might click on a little X button, but most of them are really skillful with a keyboard and just press escape because they assume that will also close it, and your connection will be gone. There's a really simple trick around it, but you just have to know about it, and that's just capturing the event and just preventing default on the body. And yeah, that's just stuff that you bump into. It's really sad, but they luckily fixed it in Firefox 20. So another really annoying bug is that Firefox can create ghost connections. And this only happens when you try to connect on a reconnect to a WebSocket when the close callback is called. And the really bad thing about these ghost connections is that they will stay alive forever. And forever is until you completely shut down Firefox. Closing your tab doesn't work. You have to completely close Firefox in order to get these connections to disconnect from your server. And there's literally nothing you can do about it. No really set timeout hacks or anything else. You're just basically just fucked. So when you want to establish how many concurrent connections you have, please rule out Firefox because of these really odd edge cases. When you're developing, don't use self-signed certificates because those are blocked on Firefox and Safari. Of course, you're not using it. It doesn't work, and it does work in production. Real time, we all do it, even on our mobile phones. But keep in consideration that these mobile providers are running behind reverse caching proxies just to make sure that your internet is fast as possible. But these reverse proxies don't support WebSockets. For example, AT&T with a 4G connection completely blocks it. The only thing around this is to use secure connections. So basically always when you're building a real-time application, use secure connections. And most of these problems will be solved by that, but not all of them. In addition to reverse proxies, we also have a really hostile user environment, and there are virus scanners such as AVG just blocking WebSockets. It's not just AVG, there are a lot of them, also Norton and all the bigger ones, they were also blocking WebSockets. So even though your browser might be supporting it, your user environment might be too hostile to use it. In addition to virus scanners, we also have firewalls that completely block WebSockets, both on the user network or on the server as well. So that's something that you need to check and make sure that these are all properly configured to allow WebSocket connections. You can't do anything about users' firewalls, but you can, of course, configure your own server connections correctly. In addition to that, load balancers, they are still not fully configured or working with WebSockets. I mean, WebSockets were introduced for like 4 years ago, and the load balancers haven't caught up yet. So if you're deploying your applications to Amazon and using elastic load balancers, you will run into this because they don't support WebSockets. The only way around this is to use your load balancer in TCP mode, but that's not optimal. So yeah, doing real time is hard if you don't know all these bugs. And yeah, what if we could just change all this? And the first solution that you'll probably think about, let's just use a framework, because frameworks fix everything, right? So yeah, this one is technically not a framework, but more a module. It's the WS module on NPM. It's super fast, it supports binary cross-domain, and all the cool kids are doing it. But as I said before, There are no, it's broken by firewalls, fire scanners. It has no fallbacks, and I'm somewhat the only maintainer of it at the moment, so it's not that awesome. And then we have the really popular Socket.io. I mean, who here has used Socket.io? Who here attempted to use it in production and failed? And everybody keeps their hands up. Yes. So yeah, Socket.io, it's really cool, but it's built for demos. I mean, let's face it, it's not something you want to deploy in production. It does support a lot of different transports. It supports WebSockets, flash sockets, long polling, JSON polling, streaming iframes. It's all nice, it's cross-domain, but it's really infested with bugs. It's also poorly and not maintained. It's basically just left for that. Nobody even gives a shit about it anymore. Socket.io 1.0 should have been released 2 years ago, but we're still waiting for it. So that's not something you want to build your applications on. But they came out with a new framework, and it's called Engine.io, and it does it a lot better. It still has multiple transports, but far less than Socket.io. It's still cross-domain, and it uses upgrading techniques instead of downgrading. What Socket.io was doing, it starts with WebSockets, and when that fails, it tries to use polling connections, and if that fails, it just tries another transport. But as these WebSockets are blocked, your first connection will be blocked, and Socket.io just completely stopped working after a broken WebSocket connection. And with Engine.io, they start with the lowest and most knowing working transport, in which is JSON polling or XHR polling, depending on your cross-domain situation. And when that's successful, it attempts to upgrade to a WebSocket connection. So if it works, it will use that instead. If it fails, it will just continue working with the polling connection. So this is great because it will allow it to work behind firewalls, fire scanners, and everything I mentioned before. But it's really not well tested yet because it's still relatively new, and there is no message order guarantee because it's using a polling transport. It could be that 2 messages that you send to the server, that the first message takes longer to process than the other one. So the last message that you send will be processed faster, and you have an inconsistent order of events. This is not really a problem for most people, but if you're building a real-time collaborative text editor, you don't want to delete a word before you've inserted it. So this does matter for some use cases. And then you have browser channel. It's not really known yet to a lot of people. It supports multiple transports. The client and actually a whole browser channel has been built by Google. It's part of the Google Closure framework. It's really cool, it's really well built. It's based on the technology that Google has been using for Gmail for their real-time components. It does support ordered messages, and it guarantees it. It works behind firewalls because it's not supporting WebSockets. It's also not cross-domain. And unfortunately, the Node version of it is built with CoffeeScript, which I absolutely hate because it's horrible to debug. And real-time should be easy to debug, and CoffeeScript just goes in the way of it. And then we have Sock.js. It has a lot of transports, more than Socket.io. I think it has like 10 different transports. It's cross-domain, but it has really poor error handling. It's so poor that they even forgot to add an on-error handler on the WebSocket connection. They don't support query strings, so you can't send any initial data to your server. You have to wait until it's fully connected for you before you can send a package. And again, more CoffeeScript. The connections stall and delay behind firewalls. It's really poorly maintained. The last major update of it was also 2 years ago, so it's almost like these frameworks die in that certain age. But there is a new maintainer now, and I hope that it will be better. But we'll see. It's also in the way of developers. It's really sandbox down, and it has header whitelisting, so you can only access certain headers of a request. So if you want to access cookies, for example, too bad, because they are blacklisted. So yeah, all these frameworks have different use cases and different APIs. It's not that bad that they all are written for different use cases, but because nobody's writing the same application. We all have different use cases, but the different APIs, that's a problem, because when you're building a project, your specifications might change. You might start out with your minimum viable product with WebSockets, and then your manager comes, oh, we also need to support IE6. And you can completely rewrite your application again just because your product specs are changing. So I came up with a solution for that, and so we can change that too, and it's called Primus. And it's a wrapper around all these popular frameworks, and it makes it easier for you just to focus on building apps instead of having to worry about real-time and all these bugs that I mentioned. And a big part of it is that we have a really growing community. It's built for self-preservation, the whole module, so everything is out in the open. Everything can be extended through external modules, third-party modules. It's growing rapidly. We just reached 1,000 stars on GitHub. We have 5 different contributors already. Make a couple of good pull requests and you're automatically added as contributor with full repository access and npm access. So it keeps the project alive. And the best part of it, it just allows you to change one line of code in your server configuration, and you will switch between all these different frameworks. All the frameworks that I mentioned are built in with the option of using your own transport. As I said before, it has like 1,000 stars and it's still growing steady. The download stats are there. It's gaining traction among the users. So it's not only gaining traction, it's also being contributed through plugins, because one of the really nice things about Primus is that it allows middleware and it allows plugins to extend the framework. So far we have 50 different plugins. They all differ from emitting functionality, rooms functionality, multiplexing, clustering, scaling out using Redis. Basically everything you want to build your own application. And the beauty of all these plugins is they all work, and it doesn't matter which framework you're using, because the API that they all communicate with is all the same. So we have an IRC channel where most of the questions are asked. If there are still questions, I consider them bugs, because it's just an indication that a documentation isn't good enough. So if you have any questions, file it as a bug, and it will be solved in the documentation. So the history, so why did I start inventing Primus? It all started out with a framework that I've written over the last year or so. I just released it a week ago, and it's called BigPipe. And a real big part of this web framework is that it uses real-time. So I started out with using Engine.io, but Engine.io is really low level. So if you want to have JSON encoding, you have to write it yourself. If you want to have to reconnect, you have to write it yourself. So I started out with basically just wrapping Engine.io to make it more usable for developers, and basically more usable for me, because I have to maintain this framework. Then I thought, it's still from the same developer. I don't want to be in the situation where he decides, oh yeah, fuck it, I'm just gonna kill this too, and then I have to rewrite a really big portion of my application and in my framework just to support something else. So I started out with building a wrapper around all these big frameworks, and then I thought, this is growing too big. It should be a separate project. So it's been extracted out and released as Primus, and that's basically it. So the main use cases for using Primus is if you're a module or a framework author and you want to include real-time functionality in your framework, you can easily use Primus and just have your developers figure out what their best use case is for their application. The best use case for the real-time framework they want to use. In addition to that, it's ideal for startups. So as I mentioned before, product specifications will always be changing, so you just have to prepare for that. And of course, web developers. It's just something you can depend on. Learning Primus is really easy. You just install Primus together with the module or the framework that you want to use. Um, and that's it. The second thing you're doing is creating a regular HTTP server, supplying it to Primus. You can optionally set the transformer to WebSockets, which is the default. If you've used Socket IO before, you will probably see the same similarities here with the connection event, when a new connection has been made to your real-time endpoint. And as you would expect, you can just write on it, listen for data events, so that when the client is writing, you can receive it on the server. And it's really easy. The client file is served from the server, just like you are used to in Socket IO. But it also allows you to just save it to disk, so you can upload it to a CDN or to your own file server and serve it from that. It uses a similar API, just new Primus with a URL. You can optionally listen for open events, but you don't have to wait for open events in order to write data. The client is smart enough to just queue all this information and wait for the open event and flush everything in one go. So yeah, the big part of it is switching, and switching is really easy. As I said before, it just allows you to change one line of code. You just say transformer sock.js, transformer socket.io. You install the framework and it's done. You don't need to make any other changes. This is just one line and you're done. And it proves a point. I mean, people are coming to the IRC channel and making them happy because they just found a bug in Engine.io and they just don't want to deal with that. And changing one line of code allows you to focus on building your app again instead of having to debug all these horrible issues. But as I mentioned before, it also allows third-party libraries. So what you can do is when you're building these libraries, you can just extend the transformer from Primus. It uses the same extend syntax that you might have seen in Backbone. The only thing you have to write is a server part and a client part, and optionally you can include a library. The server part will only be executed on the server. We stringify the client and added it to our Primus.js client file. And it's just simple as this to build your own framework. So instead of supplying the transformer property with a string, you just require your own custom transport and everything will run off this. There are already people doing this. There's a TCP-based transformer in NPM, so you can just use TCP to connect different Primus services together. One of the biggest things about Primus is not just it just wraps all these frameworks. It does a really good effort on attempting to improve the stability of it. Because we're wrapping it, we can intercept all these requests before they enter these frameworks. So we can do some modifications on that. And also when we've received the connection and we emit the connection event on the server, we can make some final changes to the server implementations of all these frameworks just to remove all these bugs. So what we've been doing for sock.js, for example, we've been adding a lot of custom bugs to their client library because we've been making pull requests, but it's taking months to just accept it. So we decided just to ship all these client frameworks in our own library and patch them ourselves. So we patch the client libraries, but we also patch the server. So as I mentioned before, sock.js has a really horrible habit of making it really hard for developers to just decide if they want to use a certain header or not. So we had to hack around it and store a copy of all headers in a header that is whitelisted by sock.js. So we can actually properly access it in Primus. The whole client is and server part is stream compatible. So if you're using streams, you can just pipe over data, and all the same APIs, methods are all supported. So you can just end the connection like you're used to with streams. You can pipe it, you can write it, and you have an end event, and that's it. It's really simple to just pipe over a JSON stream, for example, from your server logs and just show it all in real time. The encoding. Every message that we send to the server needs to be encoded. Sock.js already has JSON encoding by default, so we do double encode it there, but These other frameworks all use plain strings to be sent over the server. So we use JSON by default, but we allow different parsers to be used. We can use eJSON, which is a format that's been developed by the guys who built the Meteor framework. It's basically an extended version of JSON, which allows array buffers and doesn't transform date instances into strings, but parses it back to a real proper date instance, which is really cool. But you can also use different encodings and different parsers. It follows the same object-like structure, but instead of extending, you just pass it an object with an encoder and decoder and an optional library. So everything that's built here in Primus can be extended by the community. So if, for some odd reason, the project is not supported anymore, you can just create your own real-time framework and use that instead. A real cool thing is that we also expose the way to transform incoming and outgoing messages. So this allows you to transform the data that goes in, or even just intercept and stop this message from bubbling up to your data handlers. This is really useful when you're building plugins. For example, an emit plugin, you want to intercept a package that contains event information. When you detect that, you just return false, and no message event will be triggered. Reconnect, this is one of the vital things when you're building a real-time application. Most of these frameworks forgot to include it, but building a proper reconnect is really hard. The thing that you need to take in consideration when you reconnect or when your server crashes, every connected client will disconnect at the same time, and they will probably all attempt to reconnect to your server at the same time again, and therefore DDoS your server, preventing it from ever going online again. So what you need to do is do an exponential backoff of your server, but not just exponential backoff, but also do a randomized exponential backoff. So it doesn't come at the same time every single time. So you will be able to properly put your server back online, and we allow different strategies for reconnection, or you can configure when the reconnection needs to go. So when a connection is disconnected unexpectedly, you can set it to reconnect, or when you go offline and online again, you can configure it to reconnect again. One of the things that every framework has included is broadcasting. We do the same thing. We allow two different ways. We allow a write method, which is placed on the server of Primus, which will broadcast the message that you give it, which is basically a call to the Primus for each, which is also a method on the server, which will iterate over all the connected clients to the node process, and you can just filter out connections that you don't want to write a message to and write to those that you want to write a message to. So it also ships with a node client because you want to write tests for your real-time framework or your real-time application. So it's really simple. It follows the same API. The client is exposed as a .socket instance, so you can just create a new socket and connect to your URL. Or if you don't have a pre-existing server, you can just call the create socket with the same transformer options on your server, so the client knows which framework it needs to use to connect to your server. So as I mentioned before, plugins is really cool part about Primus. It's really easy. You can just call use, give it a string, and it will require the module, or you can just pass in a pre-required module, and everything will just work as intended. They will introduce new methods, new functionality into Primus. And the reason that we went with a plugin interface is that I want to keep the core of Primus light. Because if you start adding all this functionality, you also need to maintain it. And by keeping a really small core, makes it easier to maintain, easier to fix bugs, and doing faster releases. Our release cycle is like a new release every 2 weeks or so. And it makes maintaining really easy. It follows the same structure again as a framework. You specify a server part and a client part, and optionally a library, which will be also added to the front-end client. And that's it. It's really simple. In addition to plugins, we support middleware. These allow you to intercept all these requests before they get passed into the real-time server. So if you're using Express with sessions, you could actually use the same session middleware layer on your Primus server, so you can have a session property on your socket, which is really cool. Most of the functionality in Primus is also implemented through these middleware layers. We serve our client through a middleware layer. We add no caching headers, fix XSS errors in IE using middleware. We add a proper cross-origin resource sharing through middleware. It's really powerful, and without it, it would just not be complete. And this just allows full developer freedom. So that's it. So check out Primus if you're building real-time applications, and thanks.
Congratulations, that was a great talk.
Thank you.
Lots of questions, thank you very much. Let's see. Does Primus work with Browserify out of the box?
It doesn't work with Browserify out of the box. It's something that I have been considering, but the biggest problem is that our client needs to be compiled on the fly when you select the transformer on the server side. So in order to make it work with Browserify, we have to publish all these different versions of Primus with different transport layers to NPM so you can require it. But as we're also using plugins, and all these plugins can also extend the client and include libraries, it would just be a really hard, big task to publish a Primus-WebSocket plugin name in order to be able to have it required through Browserify.
Right, interesting. Would you use WebSockets or Primus in particular for server-to-server communication?
You can use that, but if you're using server-to-server communication, it's just better to just use a plain old TCP connection so you don't have the overhead of the WebSocket protocol.
Okay, that makes sense, yeah. What's the story for integrating authentication with WebSockets? Is it like on the message level, like do you have to, like, how does it work, basically?
Yeah, doing authorization on real-time is really hard, because the simplest thing that you might think is we're going to use basic authorization in our browsers, which works for HTTP, but it doesn't work for WebSockets. It works for most browsers except for Chrome, because Chrome isn't fully a full implementation of WebSockets. So the only thing you need to do is in Primus you can add an authorization handler, which is basically accepts a function with a request and a callback function, and you just inspect the incoming request to see if it's allowed or not based on cookies or query string parameters that's been sent to the server, and decide if you want to accept or decline the connection.
Okay. For those who are still fighting Socket.io, should they just give up that fight and switch to Primus?
Yeah, I gave up on it. I've been core contributor of Socket.io for 3 years, and I mean, it's not worth it anymore. There are so many better options available now, and with Primus it makes it just really easy. It's like using Primus, including 3 or 4 plugins, and you have Socket.io 0.1, which is ready to go.
Right. So there's 2 main points you made about Primus. The one is although the actual other implementations all suck,
yeah,
and they get abandoned. So is Primus more a statement of the quality of and the maintenance of NPM modules, or the brokenness of WebSockets in production?
Yeah.
Good question.
Yeah, it's a good question. I think most people underestimate open source software that you depend on in your production applications. They are usually just written because one person needs it and they are released as open source. But they don't understand that they also have to maintain this module, or that other people will depend on this module and expect that it's maintained. It's not software that you buy. So,
right.
It's more a maintenance question for me.
Well, and I like that, not a question, but I really like that you put emphasis on, like, I want to build this with other people so people can, like I tell other projects off for not being maintained, so the one that I do is more diverse so other people can trust it more. That's a good thing. Yeah. Do you, does Primus support, or have you thought about using WebRTC as a transport?
I've been considering using WebRTC as transport, mainly using data channels, but that would require a client-like instance to run on a server, because you want to communicate with the server and not using client to client.
Right.
Because you don't need any wrapping for different WebRTC frameworks at the moment.
Okay.
You might in the future if they start sucking.
Right. Does Primus support or have multiplexing, so you can have multiple connections going, multiple sessions going over a single connection?
It's not built into the framework, but it's built as a plugin. So we maintain a plugin called Substream, which creates volatile namespacing on top of this existing connection, which is basically just another stream, so you can just still pipe to this substream of it.
Right. If your use case is that you only need a one-way communication, say client to server to client, would you think it's worth going, like, building up that WebSocket stack, or is like the traditional long polling better, or using server-side events?
Just use server-side events.
All right.
No polling. And server-side events are just built for that specific use case.
Right.
It includes Reconnect, so it has everything that you need.
Right.
And it's not blocked by firewalls because it's just plain old HTTP.
Right. And with all the hassle that comes with WebSockets, is it worth it? Like, you definitely talked a little bit about, like, why you should, like, what the use cases are. Basically, halfway through your talk, it's like, this shit doesn't work at all, so why should we bother? Basically,
yeah,
and then you go and fix it. But still, like, that was the question from the time of the talk. It's like, is it worth?
It does add an extra experience to your site. So I think that if you can make money off it, do it. If it doesn't bring you any money, don't do it at all.
Right.
It's not worth the developer pain.
All right, excellent. That's very straightforward. All right, that's all the questions we have. Thank you very much, Arnout, and round of applause. All right, good job.
Thanks.
All right.